Now, I would like to introduce the pressure temperature ratings for cast bronze valves. The table we are looking at covers cast bronze valves according to ASTM B61 and B62 standards, and the rating criteria follow ASME B16.25. A representative alloy is C83600. The temperature range is indicated from -20 to 150 degrees Fahrenheit, which is -29 to 66 degrees Celsius. For this temperature range, operating pressure values such as 135 sig and 280 sig are provided depending on the rating, and pressures are shown in both sig and bar units. Some cells in the table are left blank with dashes where values do not apply to those conditions. There is one important note. Some codes, such as ASME Boiler and Pressure Vessel Code Section 1, ASME B31.1, and ASME B31.5, limit the maximum rating temperature of this material to 406 degrees Fahrenheit. Please keep in mind that cast bronze is a valve body material used for relatively low pressure, low temperature, non-corrosive services.
I would like to explain the nominal pipe size divisions in the cast bronze valve rating table we just saw. The pressure temperature ratings for bronze valves are presented separately for Class 125 and Class 250. Within each class, they are further divided by nominal pipe size, or NPS, into a small to medium range from NPS 1 to 12 and a large range from NPS 14 to 24. In Class 250, the NPS 14 to 24 range and the NPS 1 to 12 range are listed with separate ratings, and the same applies to Class 125, where NPS 1 to 12 and NPS 14 to 24 are distinguished. The key point is that even for the same pressure class, the allowable operating pressure changes as the nominal pipe size of the valve increases, so you must check both the class and the NPS range when reading the table.
Here, I will introduce the operating pressure rating classifications for steel-based valves. Unlike bronze valves, which use the Class 125 and 250 system, steel end valves are denoted by a rating system of Class 150 and Class 300. In the operating pressure section of the table, these two classes appear as separate headings. Generally, the higher the class number, the higher the allowable operating pressure under the same temperature conditions. You should read these class divisions in conjunction with the rating tables for the C92200 alloy of ASTM B61 and the C83600 alloy of ASTM B62 that follow.
This chunk is a heading specifying a bronze alloy standard. I would like to introduce alloy number C92200, which corresponds to the ASTM B61 standard. This alloy is one of the materials used for cast bronze valve bodies and is classified within the ASME B16.25 rating table system. Together with the C83600 alloy of ASTM B62 mentioned earlier, it forms the bronze valve material group and is primarily used for low-pressure, non-corrosive fluid services.
The following heading is for another bronze alloy standard. I would like to introduce alloy number C83600 of the ASTM B62 standard. This alloy is a standard material widely used for cast bronze valve bodies, and the ASME B16.25 rating table applies to it. It pairs with the C92200 of ASTM B61 seen previously and is used for low-pressure services in the range of -20 to 150 degrees Fahrenheit, or -29 to 66 degrees Celsius.
Next, we turn to dimensions and standards.
Next, I will introduce the face-to-face dimensions for flanged globe-style control valves. We previously covered cast bronze valve materials such as ASTM B61 C92200 and B62 C83600, and from here we move to the table that defines the installation dimensions for those valves. The pressure classes covered by this table are Class 125, 150, 250, 300, and 600, all of which are dimensions according to the ISAS 75.03 standard. Face-to-face distance refers to the length between the faces of the flanges on both sides of the valve. This is a critical installation dimension that determines compatibility when designing piping layouts or replacing an existing valve in the same spot. The table defines standard lengths for each pressure class based on the valve size. The applicable dimensions vary depending on the end type and material combination. For example, whether it is Class 201 raised face cast iron or Class 300 raised face steel. Therefore, when selecting a valve, you must check not only the size but also the class and end material to apply the correct face-to-face distance.
Now, I will introduce the end connection classification items in the face-to-face dimension table for flanged globe-style control valves. This part is one of the column headers in the table, referring to CL300RF steel, which means a steel material valve with a Class 300 rating and a raised face sealing surface. The entire table follows the ISA S75.03 standard and covers Class 125, 150, 250, 300, and 600 ratings. A raised face is a form where the flange sealing surface is slightly protruding, and it is the most widely used standard end connection method for steel valves. In the table, pressure ratings and materials are paired, with CL250RF corresponding to cast iron and CL300RF corresponding to steel. The face-to-face distance mentioned here means the distance from the inlet flange face to the outlet flange face, which is a key dimension that must be verified when installing a valve in a pipeline.
Now, let's look at the face-to-face dimensions for flanged globe-style control valves. This table follows the ISA S75.03 standard and covers Class 125, 150, 250, 300, and 600 ratings. The horizontal axis lists the end types. Class 125 flat face is cast iron, Class 150 raised face and ring-type joint are steel, Class 250 raised face is cast iron, and Class 300 raised face is steel. Here, FF stands for flat face, RF for raised face, RTJ for ring-type joint, CI for cast iron, and STL for steel. Looking at the specific values, for NPS 1/2 in and 3/4 in, the Class 125 flat face is 7.25 inches, Class 150 raised face is 7.75 inches, and Class 300 raised face is 8.00 inches. For NPS 1.5 inches, these are 8.75, 9.25, and 9.88 inches, respectively, and for NPS 2.5 inches, they increase to 10.88, 11.38, and 12.25 inches. The key point is that for the same valve bore, the face-to-face distance gradually increases as the pressure class increases and the end type becomes larger.
Next, I will introduce the pressure ratings and end connection methods. As an extension of the previous face-to-face table, Class 300 ring-type joint steel ends and Class 600 raised face steel ends are added here. RTJ, or ring-type joint, is a method of sealing by inserting a metal ring into a groove, providing highly reliable sealing in high-pressure and high-temperature environments, which is why it is often adopted for high-pressure ratings of Class 300 and above. Even for the same valve bore, as you move from Class 300 to Class 600, the valve is designed to handle higher operating pressures, and accordingly, the flange thickness and face-to-face distance also increase. These items are the parts that continue into the columns corresponding to high-pressure ratings in the face-to-face table we saw earlier.
Continuing on, I will introduce the face-to-face dimensions for higher pressure ratings. The last column of the previous table includes the Class 600 ring-type joint steel end, and from here, a new table begins. The new table covers the face-to-face dimensions for flanged globe-style control valves corresponding to Class 900, 1500, and 2500, and the dimension standard is the ISA S75.16 specification. Unlike the Class 125 to 600 range we saw earlier, which followed S75.03, these ultra-high pressure ratings manage face-to-face distances with a separate standard. Because higher pressure ratings require thicker flanges and longer face-to-face distances, you must verify this standard distinction during piping design.
Now, I would like to introduce the detailed face-to-face dimensions for Class 900, 1500, and 2500. The most notable feature of this table is that it provides two face-to-face patterns for each class, short and long. Looking at the representative values for the NPS 1/2 in to 1 inch range, Class 900 has a short dimension of 10.75 inches and a long dimension of 11.50 inches, while Class 2500 is 12.21 in for short and 12.50 inches for long. For NPS 1.5 inches, Both Class 900 and 1500 are 12.25 inches. 4 short and 13.1 inches. 4 long, and Class 2500 increases to 14.1 inches. 4 short and 15.00 inches. For long. As we move to larger diameters, Class 2500 only provides one pattern for some sizes, which is why you see empty cells marked with dashes in the table. The reason for offering both short and long options is to flexibly accommodate the space required by the actuator and trim, as well as to ensure compatibility with existing piping.
Next, I will introduce the face-to-face dimension table for butt-weld-end globe-style control valves. Butt-weld ends are a method of connecting the valve directly to the piping via welding, without using flanges. The pressure classes covered in this table are Class 150, 300, 600, 900, 1500, and 2500, and the dimensions are based on the ISA S75.15 standard. Unlike flanged connections, weld ends have fewer leak paths because they lack gaskets and bolted joints, making them particularly advantageous for high-pressure or high-temperature service. However, since the valve is difficult to remove once welded, maintenance plans must be considered together.
I would like to introduce the face-to-face dimensions for socket weld-end globe-style control valves. This table is based on the ISA 75.12 standard and defines the distance between the two ends of the valve, known as the face-to-face dimension. The pressure classes are divided into 3 main groups: Class 150, 300, and 600 as one group, Class 900 and 1500 as another, and Class 2500 separately. Each class has 2 patterns, short and long, and dimensions are listed in both millimeters and inches. Valve sizes are categorized by DN and NPS, ranging from NPS 1/2 in to larger sizes. For example, for NPS 1/2 in, the short dimension is 7.38 inches, and the long is 8.00 inches. For Class 150, 300, and 600, while for Class 2500, it is 8.50 inches. 4 short and 12.50 inches. For long, for NPS 1.5 inches is 8.75 inches. And 9.88 inches, and for Class 900 and 1500, it is 9.25 inches, and 13.00 inches. As you can see, as the pressure class increases, the face-to-face dimensions also increase, reaching up to the 50.00 inches. Range for Class 2500. Cells marked with 3 dashes indicate that the specific size and class combination is not applicable, so you must select only the applicable combinations from this table during piping design.
I will now introduce the title and reference standard for the dimension table we just saw. This is the face-to-face dimension table for socket weld-end globe-style control valves, with applicable pressure classes of Class 150, 300, 600, 900, 1500, and 2500. The reference standard for these dimensions is ISA S75.12. Socket welding is an end connection method where the pipe is inserted into the valve and then welded. This title clarifies which standard the numerical data on the previous slide is based on. Since face-to-face dimensions vary depending on the end connection method, you must apply these standard dimensions if socket weld ends are selected.
I would like to introduce the face-to-face dimensions for screwed-end globe-style control valves. This table also follows the ISA S75.12 standard and applies to valves with screwed-end connections. The pressure classes are grouped as Class 150, 300, and 600, Class 900 and 1500, and Class 2500 separately. Each class has short and long patterns, with dimensions provided in both millimeters and inches. For example, for NPS 1/2 in, the short dimension is 6.69 inches, and the long is 8.2 inches. For the Class 150 to 600 range, and for Class 2500, it is 8.50 inches. For short and 12.50 inches. For long, for NPS 1.5 inches, it is 9.25 inches, and 9.88 inches. For Class 900 and 1500, it is 9.25 inches, and 13.00 inches, and for Class 2500, it is 10.25 inches, and 15.00 inches. Some sizes, such as NPS 2.5 inches, are marked with dashes, indicating that the combination is not applicable. Even for the same valve size, the face-to-face dimensions, especially the long pattern, increase as the pressure class rises, reaching up to 26.00 inches and 29.00 inches for large class 2500 valves.
I will now introduce the data for the small size range of the globe valve face-to-face dimension table. These rows provide short and long face-to-face dimensions for each valve size, categorized by DN and NPS. For NPS 1/2 in, the short is 6.50 inches, and the long is 8.2 inches. For NPS 3/4 in, the short is 6.50 inches, and the long is 8.25 inches. For NPS 1 inch, it is 7.75 inches and 8.25 inches, and for NPS 1.5 inches, it is 9.25 inches and 9.88 inches. For NPS 2 inches, it is 10.50 inches and 11.25 inches, and for NPS 2.5 inches, it is 11.50 inches and 12.26 inches. With this two-column structure of short and long, you can easily compare the dimensional difference based on which face-to-face pattern is selected for the same valve size.
I would like to introduce the face-to-face dimensions for separable, flanged, globe-style control valves. This table follows the ISA S75.20 standard and applies to the separable flange type, where the valve body and flange are separate. The applicable pressure classes are Class 150, 300, and 600, with dimensions listed in both millimeters and inches. As the class increases, the face-to-face dimensions increase for the same size. For example, for NPS 1.5 inches, it is 3.62 inches. For Class 150, 3.88 inches. For Class 300, and 4.1 inches. For Class 600, 4 NPS 2 inches is 4.37 inches, for 0.62 inches, and 4.94 inches, and for NPS 3 inches, it is 5.88 inches, 6.25 inches, and 6.62 inches. For larger sizes, it ranges from 8.88 inches, 9.31 inches, and 10.00 inches, up to 10.69 inches, 11.19 inches, and 12.00 inches. This table also includes a supplementary table organized in a single column for the same class, where dimensions increase from NPS 1.5 inches, in the order of 8.50 inches, 9.50 inches, 11.50 inches, 14.00 inches, and 17.00 inches.
I would like to introduce the face-to-centerline dimensions for raised face angle style valves. This table follows the ISA S75.22 standard. Because angle valves have an inlet and outlet that bend at a right angle, they are defined by the face-to-centerline dimension, the distance from one face of the valve to the valve centerline, rather than the face-to-face dimension, which is the distance between the two end faces as seen in standard globe valves. The applicable pressure classes are Class 150, 300, and 600, and dimensions are provided in both millimeters and inches. The end connections are specifically for raised face or RF flanges. When installing an angle valve in a right angle piping section, you must use this face-to-centerline dimension to position the piping for a precise fit.
I would like to introduce the face-to-face dimension standards for flangeless, partial ball control valves. This table covers Class 150, 300, and 600, and the dimensions follow the ISA S75.04 standard. Looking at the face-to-face dimensions, NPS 3/4 is 3.00 inches, and NPS 1/2 is between 4.50 and 4.88 inches. As the valve size increases, the dimensions increase to 6.50, 9.00, 11.69, 15.75, 18.00, and 24.00 inches. In the separately provided NPS to DN conversion table, NPS 1/2 corresponds to 1.31 inches, which is 33.3 millimeters, followed by 1.69 inches, S42.9, 1.81 inches, S46.0, 2.06 inches, S52.3, 2.38 inches, S60.5, 3.06 inches, S77.7, 4.00 inches, S101.6, and 4.38 inches, S111.2 millimeters. Two notes are important. First, these valve bodies are compatible with Class 125 cast iron flanges or Class 150 steel flanges. Second, the face-to-face dimensions in the table are based on the valve after it is installed in the pipeline. If separate gaskets are used, their thickness is not included. However, gaskets or seals that are an integral part of the valve are included in this dimension in their compressed state.
I would like to introduce the face-to-face dimension standards for butterfly control valves. This dimension table covers both single flange, or lug type, and flangeless, or wafer type, butterfly valves. The applicable classes are Class 150, 300, and 600, and the dimensions follow the MSS SP 67 standard. Please keep in mind that the lug type is bolted from both sides, while the wafer type is installed by being sandwiched between two flanges.
I would like to introduce the face-to-face dimension standards for high-pressure butterfly valves with offset design. This dimension table is for high-pressure butterfly valves with an offset design, where the disc axis is positioned away from the center of the seat, and the applicable classes are Class 150, 300, and 600. The dimensions follow the MSS SP 68 standard. The table presents separate items for narrow body dimensions and post-installation reference dimensions. The offset design separates the disc rotation axis from the seat centerline to reduce friction from the disc scraping the seat during rotation, which reduces seat wear and improves shutoff performance at high pressures.
Next, we turn to material compatibility.
I would like to introduce the wear and galling resistance chart for control valve trim material combinations. This chart evaluates resistance to wear and galling, a phenomenon where surfaces stick and become damaged when two materials slide against each other. There are three ratings: P for poor, F for fair, and S for satisfactory. Relatively soft alloy groups, such as 304 and 316 stainless steel, Inconel 600 and 625, Manel 400, Hastelloy B2 and C276, titanium, nickel, and alloy 20, mostly show P or F ratings when combined with each other, and show an F rating when combined with bronze. On the other hand, hard or surface-treated material groups, such as Type 416 hard and 440 hard, 17 to 4 pH, alloy 6, co-CRA, electroless nickel coating, ENC, chrome plating, and aluminum bronze, show relatively superior resistance with F to S ratings. Face-to-face dimensions are also included in the same table. For Class 150, 300, and 600, the dimensions increase as the NPS increases, ranging from 1.88 to 6.06 inches, 1.88 to 7.1 inches, and 2.21 to 9.13 inches, respectively. Finally, please note that Manel and Inconel are trademarks of Special Metals Corporation, and Hastelloy is a trademark of Haynes International.
Following the previous wear and galling resistance chart, I will now introduce the legend and the list of materials included. The rating symbols mean S for satisfactory, F for fair, and P for poor, and the formal name of this chart is the Wear and Galling Resistance Chart of Material Combinations. Hard and wear-resistant materials appearing in this chart include alloy 6, co-CRA, Type 440 hard, and Type 416 hard. The alloy group includes Hastelloy C276 and B2, titanium, alloy 20, and nickel. Surface-treated materials, including aluminum bronze, chrome plating, and 17 to 4 pH, are also listed. Among these, Hastelloy is a trademark of Haynes International.
Now, I would like to introduce the seat leakage class classifications for control valves. These classifications follow the ANSI/FCI 70-2 and IEC 60534 standards and are divided from Class 1 to Class 6. First, Class 1 is the most lenient grade, where no separate leakage test is required provided the user and supplier so agree. Class 2 allows leakage up to 0.5% of rated capacity using air or water between 10 and 52 degrees Celsius or 50 to 125 degrees Fahrenheit, as the test medium. Next, Class 3 allows up to 0.1% of rated capacity, and Class 4 allows up to 0.01%, becoming progressively more stringent. For Class V, leakage must not exceed 0.0005 milliliters per minute of water per inch of orifice diameter per side differential. In SI units, this corresponds to 5 times 10 to the power of negative 12 m3 per second of water per mm of orifice diameter per bar differential. Finally, the most stringent, Class 6, must not exceed the leakage amount specified in a separate table based on port diameter, using air or nitrogen between 10 and 52 degrees Celsius as the test medium. As the class increases, the allowable leakage decreases, so you should select the appropriate leakage class based on how critical the shutoff performance is for your specific application.
Now I will introduce the testing procedures and test pressures used to determine the valve seat leakage class. This is part of the seat leakage classification table according to ANSI/FCI 70 to 2 and IEC 60534-4, and this section explains the testing procedures and test pressure columns located on the right side of the table. It specifies what pressure is applied to the valve inlet for each leakage class, how the closing thrust provided by the actuator is applied, and how the leakage flow is stabilized and measured. The key is that the test pressure is capped by either the operating differential pressure or the ANSI body rating depending on the class, and that the specified maximum actuator thrust is used, with no additional thrust applied even if it is available during the test.
First is the procedure for classes tested at relatively low differential pressures. In this case, pressure is applied to the valve inlet, while the outlet is either open to the atmosphere or connected to a measuring device with low head loss. Then, the full normal closing thrust provided by the actuator is applied. The applied test pressure is either 3 to 4 bar, which is 45 to 60 sig, or the maximum operating differential pressure, whichever is lower. The point here is to use the lower value between the specified test pressure and the actual operating differential pressure as the baseline.
Next is the testing procedure for more stringent classes. In this case, the entire valve body cavity and connected piping are filled with water, and then the valve plug is stroked to the closed position. The thrust used is the net specified maximum actuator thrust, and no more thrust is applied even if it is available during the test. Sufficient time is then allowed for the leakage flow to stabilize. The applied pressure is the maximum service pressure drop across the valve plug, which must not exceed the ENSI body rating, although a lower pressure may be used if agreed upon by the user and supplier.
Finally, we have the testing procedure for the most stringent class. In this case, pressure is also applied to the valve inlet, but the actuator is adjusted to the specified operating conditions, and the full normal closing thrust is applied to the valve plug seat. After waiting for the leakage flow to stabilize, the leakage amount is measured using a suitable measuring device. The test pressure is either 3.5 bar, which is 50 sig, or the maximum rated differential pressure across the valve plug, whichever is lower. Please keep in mind that as the class increases, the procedures are designed so that the test conditions more closely resemble actual operating conditions and the measurements become more precise.